We are going to look at radical and rational equations and expressions today. And so we will start with just reviewing properties of exponents. So for the SATs, it is not important that you know the name of the property, just instead that you know how to use it. So in the first one, that product of powers property just essentially tells you that if you have the same base, we can add exponents together. Power of a power property tells us that if we have an exponent raised to another exponent, then we can multiply those exponents. If you have the power of a product property, that tells us that we can basically distribute that exponent to the parentheses. You do want to be careful here with the power of a product. We cannot do, if it's a plus b to the n, we cannot distribute the exponents. So that's not an a to the m plus b to the m. So really be careful. It's only if you're multiplying. We can't do it for addition or subtraction. Quotient of powers property tells us that we can subtract our exponents when we're dividing. And then negative exponents, essentially, I like to say that they move location. So if they're in the numerator, they move to the denominator to become positive. If they're in the denominator, they move to the numerator. Zero exponent property tells us that anything to the zero power is just equal to 1. And then the quotient property, or power of a quotient, tells us again that we can distribute that exponent if we're dividing. So similar to the power of a product property. So we're going to use these to do some examples. And so a lot of these, you've got multiple things going on. Just kind of clean up one section at a time. Like I like to clean up the numerator and then the denominator and then work top to bottom. So in question 1 here, I can combine these. This is really a 2 times negative 1, so that'll be a negative 2. And then k to the third, this is really a k to the first. So I can add those exponents. In the denominator, I have a power raised to a power, so I can multiply those. And then any negative exponents move location. So this k to the negative 2 is going to move up top. So I've got negative 2k to the 4th, and now this is a positive 2, so k squared. Now I can add those exponents. So negative 2k to the 6th. You can have negative bases. So this negative 2 here is fine. It's just no negative exponents. Over here, again, similar idea, just to clean this up. This is a 2 to the first, so I would distribute exponents here to make that a 2 to the 4th n to the negative 8, and then we've got a negative 2 n to the 3rd. I can distribute my exponent here and make this an n to the negative 3. So then what I can do is I can take 2 to the 4th so that I can combine it with this negative 2. So 2 to the 4th is really 2 times 2 times 2 times 2. So 2 times 2 is 4, times another 2 is 8, and then times another 2 is 16. Then 16 times negative 2 is going to be a negative 32. I can add these exponents together, so that will be an n to the negative 5. And then I've got an n to the negative 3. And then I can subtract my exponents since I'm dividing. Negative 5 minus negative 3 is going to be negative 2. And then again, negative exponents move location. This is really to the positive 1 with that 32. So the negative 32 is going to stay in the numerator, and then the n to the negative 2 moves to the denominator to become positive. So here are just a few examples, this time dealing with roots. So when you have something like the 6th root, you're looking for groups of size 6. And I'm going to show you this here, but you don't need to rewrite it this way. R to the 6th is really R times itself 6 times. C to the 18th is 18 C's. So you have a group of 6 R's, and then we have 1, 2, 3 groups of 6 C's. So when we pull those out of the radical, it's just an R to the first, since there's 1 group of R's, and then a C to the third, since there's 3 groups of C's. But if you think of it instead of, okay, 6, I can take out 3 6s from 18, that's where I get the C to the third. I can take out 1 6 from R, or from the 6, that's where I get the R to the first. So you don't have to draw out all those R's and C's like I have. Here's another example, this time with rational or fractional exponents, but it's the same idea as what we saw before. I would say just simplify one piece at a time. So 56 divided by 7, I can do that pretty easily. I know that that's 8. Then when I go to deal with my a's, I'm dividing, so I'm going to subtract those exponents. That's really an a to the first. So off to the side over here, I can say, okay, 1 minus 5/6. Maybe I look at that and I know that that's 1/6. If I don't know that that's 1/6, I can make this a common denominator. So 1 is really 6/6. Then I can subtract the numerators to get 1, keep the denominator to get 6. So my exponent for a is 1/6. Then for b, there's nothing to combine that with, so that's going to stay a b to the 3/4. C has nothing to combine it with, but it's a negative exponent, so it needs to move to the numerator to become positive, so c to the positive 3. So this problem looks really overwhelming, but really the hardest part was just doing 1 minus 5/6. Everything else was pretty straightforward. If you're adding or subtracting with exponents or radicals, you really can only combine like terms. So here you have a 15, a to the 4th, b to the 2/3. Here it's a to the 4th, b to the 2/3. So this is really the same. It's like saying 15x plus 8x. We're going to keep what I have in a rectangle the same and just add those coefficients. So 15 and 8 gives us 23. And then we keep the a to the 4th, b to the 2/3. Same idea with the roots. If the roots are the same, we can combine them. These roots are not the same. However, we can simplify the roots before we just say that we can't do anything. So here it's the 4th root. So for this u to the 7th, we can take out a group of u's. If we take out a group of 4, there's a u to the 3rd left. So it'll be 4th root 5u to the 3rd. Here we can do something similar. We can't take out any u's, but this 80 we can break down with the factor tree. This is 8 and 10. 8 is 2 and 4. 4 is 2 and 2. 10 is 2 and 5. So I have a group of 4 2's that can come out of that radical to go with the u that's already out there. And then I have the 4th root of this leftover 5, and then there was a u to the 3rd. Now these are, both u times the 4th root of 5u to the 3rd. So what I have circled is the same, so I can just subtract the coefficients. 10 minus 2 is 8. And then it stays, I forgot my u times the 4th root of 5u to the 3rd. If you're trying to solve equations with roots or with rational exponents, you start by isolating the radical, which is just the root, or the rational exponents, and then you're going to raise both sides of the equation to a power to get rid of the root. So if you have a square root, you would square both sides. If you have a cube root, you would cube both sides. So here's an example, and this one's actually pretty tricky. We want to isolate this square root, so I'm going to move that 3 over. This becomes x minus 3 equals square root of 6x minus 26. And what makes this tricky is that I have to square this right-hand side to get rid of that square root. I also have to square the left-hand side, but I can't say that this is x squared minus 9. This is really x minus 3 times x minus 3. And I'm going to have to distribute. So when I do that, I get x squared minus 3x minus another 3x, and minus 6x plus 9. And so in order to solve a quadratic, I always want to set it equal to 0 to see if I can factor. If not, I'm going to have to use the quadratic formula. So this will be an x squared minus 12x plus 35 equals 0. So I'm going to try and factor here. X times x gives me x squared. I need to try and get two numbers that will multiply to give me 35, that will add or subtract to give me a negative 12. So if I try a 7 and a 5, if they're both negative, that will multiply to give me negative 35, or I'm sorry, positive 35, but then my outside term is a negative 5x and my inside term is a negative 7x, which will add to give me that negative 12x. So it'll give me x equals 7 and x equals 5 for my solutions. So your assignment is the radical and rational exponents, and then also radical and rational equations under the Passport to Advanced Math.